Hi there, I'm Tommy and I will be helping you through our problem today. Our problem deals with Newton's law of cooling and how long it takes for cookies to cool. These cookies are for Santa, of course, and my good friend Rachel has whipped up a batch for him. They should be just about done baking, so let's go check them out. Ah, Christmas. It's the most wonderful time of the year. The lights are out, the stockings hung, and cookies baked. It's going to be a wonderful... Wait, what are you doing?
What?
Are you going to take your freshly baked cookies off the cookie sheet right now?
Well, yes, they finished baking.
Ah, they may be finished baking, but if you eat them now, they shall be too hot to eat. You could burn your tongue and not be able to taste for a week.
So, how long do I have to wait?
Well, let's use our good friend Newton and his law of cooling to help figure out how long we should wait. This here is Newton's law of cooling. Our research team took this formula and figured out how to use it so we can see how long we have to wait for our cookies to cool. As you can see, this is a differential equation. The uppercase t stands for temperature, the lowercase t for time. T sub A stands for the temperature of your surroundings, which is kind of like the room temperature. And K is a proportionality constant specific to the object of interest, which in this case would be our cookies. To get to the fancy simplified version of this differential equation, you have to use separation of variables. Move all the uppercase t's over to one side and all the lowercase t's to the other. Then take the integral of both sides, in which case on the left side you should get ln of uppercase t minus uppercase t sub a equaling negative kt plus c. Then raise both sides to the power of e, and that will get rid of the natural log on the left side. After that, bring the c down on the right side, and you shall end up with t minus t sub a equaling c times e to the power of negative k times t. Add over the t sub a to the right side, and you get the very pretty version of this differential equation, and this is what we are going to use to solve our problem. Now for our problem. A fresh batch of cookies have just come out of the oven for Santa at a temperature of 80 degrees Celsius. After 2 minutes, the cookies cool to 60 degrees Celsius. If Santa likes to eat his cookies at 40 degrees Celsius, how long would he have to wait until they cool down to 40 degrees Celsius? Assume that T sub A, the surrounding temperature, is equal to 20 degrees Celsius. Alrighty. Let's first start by writing down everything that we are given. Let's write down the equation that we have, which is temperature as a function of time is equal to C times e to the negative k times t plus t sub a. We are also given that t sub a is equal to 20 degrees Celsius, t of 0 is equal to 80 degrees Celsius, and t of 2 is equal to 60 degrees Celsius. Now we are going to solve for c. We're going to use our initial value of T0 equaling 80 degrees Celsius as a start. So what we're going to do is we're going to replace uppercase T with 80 degrees Celsius and lowercase t with 0 and T sub A with 20 degrees Celsius. We end up with 80 equaling C times e to the negative k times 0 plus 20. Well, e to the 0 power is just 1, so we're left with 80 equaling c plus 20. And then you subtract over the 20 and you get c equaling 60. Now we're going to solve for k. We're going to use the time at 2 seconds equaling 60 degrees in Celsius, this t sub a equaling 20 degrees Celsius, and we now know c equaling 60. So when you rearrange all of that, you get 60 equals 60 times e to the negative k times 2 plus 20. First you subtract over the 20, giving you 40 equaling 60 e to the negative 2 times k. Divide over the 60, you're left with 2/3 equaling e to the negative 2k. Natural log both sides to get rid of the e, and divide over the negative 2, and you are left with k equaling negative 1/2 natural log of 2/3. Now that we know c and k, we are ready to solve for how long it takes for our cookies to cool to 40 degrees. We're going to substitute in 40 for our temperature, and we're going to plug in our values for c, k, and t sub a to our equation. That gives us 40 equals 60 times e to the 1/2 natural log 2/3 times t plus 20. Subtract over the 20 and you get 20 equals 60 times e to the 1/2 natural log 2/3 times t. divide over 60, you get 1/3 equals e to the 1/2 natural log 2/3 times t. You're going to natural log both sides to get rid of the e, and now you have natural log of 1/3 equaling 1/2 times the natural log of 2/3 times t. Now, you want to isolate t, so divide over the 1/2 natural log 2/3, and you end up with t equaling 2 times natural log 1/3 over natural log of 2/3. You punch this into your calculator since we cannot do this in our heads, and you get approximately 5.42 minutes. So Rachel, you're going to have to wait 5.42 minutes before you can eat your cookies.
Ah, okay, that makes sense. Thanks, Newton's Law of Cooling.
Yes, thank you indeed. Well, that ends this tutorial. Thank you for watching, and I hope you enjoyed it.